Introduction to Artificial Intelligence. Do you know that artificial intelligence is everywhere around on your smartphone, in automobiles, hospitals, and many other aspects of your life? Artificial intelligence records and analyzes things you do every day, and humans make decisions based on those things. Artificial intelligence recommends merchandise you might like to buy on the internet. Alerts you if your smartwatch or fitness band detects low oxygen in your bloodstream, inflammation, or an unhealthy spike in blood sugar. Scans your social media posts to learn more about what you are thinking. Helps banks invest money in your family's bank accounts to keep the economy around you growing. Welcome to the Introduction to Artificial Intelligence course. In this course, you'll become familiar with fundamental artificial intelligence, AI, concepts, such as types of AI, methods that AI uses to find connections and make predictions, and ways that humans can interact with AI systems. Learning objectives. After completing this course, you should be able to define artificial intelligence, differentiate between AI and augmented intelligence, describe 3 levels of artificial intelligence, describe the history of AI, from the past to the possible future. Define and describe machine learning. Differentiate between structured, unstructured, and semi-structured data. Describe how machine learning structures unstructured data. Describe how machine learning uses probabilistic calculation to solve problems. Describe 3 methods by which machine learning analyzes data. Describe an ideal relationship between humans and machine learning. About this module. Module 1. What is artificial intelligence? Introduction. In this module, you will learn about what artificial intelligence, AI, is, what it does, and the 3 levels of predictions that AI can make. Narrow, broad, general. Learning objectives. After completing this module, you should be able to define artificial intelligence, differentiate between AI and augmented intelligence, describe 3 levels of artificial intelligence. What is AI? AI plays an often invisible role in everyday life, powering search engines, product recommendations, and speech recognition systems. Artificial intelligence, AI, refers to the ability of a machine to learn patterns and make predictions. AI does not replace human decisions, instead, AI adds value to human judgment. In its simplest form, artificial intelligence is a field that combines computer science and robust data sets to enable problem solving. Reflection. What do you think? Take a moment to think about your answer to this question. How would you describe what AI does? Try to distill your response down to just a few words. You might be surprised by the way IBM research scientists describe today's AI. Spoiler. It doesn't involve thinking, deciding, or taking over the world. Read on to discover what AI really does. When you have that in mind, you'll be ready to dive into the things AI can accomplish and what it can help humans accomplish. What is the difference between AI and augmented intelligence? When learning about artificial intelligence, you'll come across the term augmented intelligence. Both terms share the same objective, but have different approaches. Augmented intelligence has a modest goal of helping humans with tasks that are not practical to do. For example, reading 1,000 pages in an hour. In contrast, artificial intelligence has a lofty goal of mimicking human thinking and processes. However, it's important to note that AI today is not mature enough to perform independent tasks such as diagnosing cancer. Watch the following video to learn about the differences between artificial intelligence and augmented intelligence. Video transcript. Artificial intelligence versus augmented intelligence. I want to share with you the story of how I got to work today. I submit to you that my drive from my home to my office used 3 forms of intelligence. The first intelligence was human intelligence. The intelligence there was the intelligence that I needed to operate the vehicle, to turn the steering wheel, to check my mirrors. The second form of intelligence was artificial intelligence. Once I got on the highway, I turned on the Self-driving feature in my car. Fancy. Now the car stayed in its own lane, kept an appropriate distance from the vehicle in front, and maintained a proper speed. No input from me at all. When I got off of the highway, I used a third form of intelligence, augmented intelligence. Augmented intelligence, well, that took the form of all the driver assist features in the vehicle, things like collision detection, to alert me if I got too close to the car in front, and blind spot avoidance to tell me if there was a vehicle alongside me as I changed lanes. Artificial intelligence. Well, that is the ability for machines to perform tasks that normally require human intelligence, such as reasoning, natural communication, and problem solving. It basically replaces the need for a human. So, computers doing the work as humans not really needed. And the artificial intelligence performs certain tasks and makes decisions, and it's incorporated into so many systems today. Now contrast that with augmented intelligence. Now this is where you have machines. And you have humans both working together. And they're doing so to enhance each other's efforts when completing tasks. Augmented intelligence systems augment human abilities, things like screen readers for the blind, voice-driven navigation, or my in-car collision avoidance system. They're all examples of augmented intelligence at work. They act on our behalf in the physical world, but in a way that complements our own capabilities. So, artificial or augmented? Which form of intelligence will give us the best results for a given problem? Well, to answer that, let's create a strength matrix. So, machines versus humans. Now, one thing machines are great at is ingesting large amounts of data. They can take in more data at a faster rate than any human could, and they also don't get tired, so they can just keep going and going, ingesting that data as they go. Machines are especially good at things like repetitive tasks, and to do so in a way that is reliably accurate. Unlike my spelling of repetitive. So, if you need to quickly analyze a lot of data or do something over and over again with no margin for error, and then specifically artificial intelligence is really your best bet. Now, on the other hand, us humans, well, we have a few advantages, too. We're very good at generalizing information. We can take a single piece of data and understand the concept that it represents. We're also very good at creativity. We can come up with ideas, we can solve problems, and communicate our findings in a way that, well, machines just can't. And we have emotional intelligence, too. And that's a big benefit, where we can understand the reactions of others, and it's critical for tasks like customer service or caregiving. Now, augmented intelligence is really a sweet spot that combines all of these human strengths with a bit of a helping hand from our machine counterparts. By using AI to help us see and understand the world in new ways, we are able to do things that would be impossible for us humans on our own. So, which form of intelligence is best? The answer is both. And that's why I love augmented intelligence. It's how humans will continue to thrive and lead in the world and get me to work safely. If you have any questions, please drop us a line below, and if you want to see more videos like this in the future, please like and subscribe. Thanks for watching. So, what continues to drive the development of AI? As computing power and algorithms become more powerful and data volumes increase, companies will adopt new use cases for AI technologies. Companies will embed smart systems into their applications to drive innovation and efficiencies, enhance employee experience, automate tasks, decrease costs, and improve revenue. Next, you'll explore what AI does and the different predictions that AI can make. What does AI do? Artificial intelligence machines, researchers call them AI services, don't think. They calculate. They represent some of the newest, most sophisticated calculating machines in human history. Some can perform what's called machine learning as they acquire new data. Others, using calculations arranged in ways inspired by neurons in the human brain, can even perform deep learning with multiple levels of calculations. Imagine you are given the job to sort items in the produce department at a grocery store. You realize that there are dozens of products and very little time to sort them manually. How could you use artificial intelligence, machine learning, and deep learning to help with your work? Artificial intelligence. To separate the stone fruits, berries, and tropical fruits, you could create a programmed rule in the format of if-else statements. This allows the machine to recognize what is on the label and route it to the correct basket. A programmed rule might look something like this. If berries is on label. Route items to center basket. Else. Redirect item to main basket. Artificial intelligence makes this process more efficient. Machine learning. To improve the performance of the machine, you expose it to more data to ensure that the machine is trained on numerous characteristics of each type of fruit. The more data you provide for the algorithm, the better the model gets. By providing more data and adjusting parameters, the machine minimizes errors by repetitive guesswork. Deep learning. The grocery store has expanded its produce selection to include more varieties such as nectarines and plums, stone fruits, blackberries and cranberries, berries and mangoes and star fruit, tropical fruits. In addition, the products now come in different sizes, shapes, and colors. What makes deep learning different? Deep learning models eliminate the need for feature extractions. For your work in the product department, you decide to use algorithms based on deep learning to sort fruit by removing the need to define what each product looks like. Feature extraction is built into the process without human input. Once you have provided the deep learning model with dozens of fruit pictures, it processes the images through different layers of neural networks. The layers can then learn an implicit representation of the raw data on their own. How do AI services calculate? And, what do they do with those calculations? Let's break this down into two parts. Analysis. AI services can take in, or ingest, enormous amounts of data. They can apply mathematical calculations to analyze data, sorting and organizing it in ways that would have been considered impossible only a few years ago. Prediction. AI services can use their data analysis to make predictions. They can, in effect, say, based on this information, a certain thing will probably happen. This is what AI services do. Based on data analysis, they make predictions. It might not seem like much, but that analysis and those predictions can have an enormous impact on human life. Before you move on, take a moment to compare analysis and prediction to the guess you made earlier. Are you surprised? If so, you might be wondering how those two seemingly simple actions can be so important. What predictions can AI make? Most people have a love-hate relationship with the autocorrect feature on phones or computers. What's happening when you enter a misspelled word? And how does the machine know to suggest a better spelling? Simply put, the software analyzes what you've typed so far and predicts a likely correction. Your phone or computer, or its online service, has more than just a dictionary of correct spellings. It has a huge library of phrases that humans use in certain contexts on many subjects. So, when you enter a word that's not in its dictionary, it begins analyzing and predicting and suggests the word you need. Predictions aren't always accurate. But if they're correct often enough, they're useful and can save you time. Here are more ways that AI uses data to make predictions. Human language. Online chatbots use natural language processing, NLP, to analyze poorly typed or spoken questions, then predict which answers to give on topics ranging from shipping or business hours to merchandise and sizes. Vision recognition. AI helps doctors identify serious diseases based on unusual symptoms and early warning signs, and it reads speed limit and stop signs as it guides cars through traffic. Fraud detection. AI analyzes patterns created when thousands of bank customers make credit card purchases, then predicts which charges might be the result of identity theft. This is AI, presented by IBM Video Transcript. This is AI, presented by IBM, starts now. Artificial intelligence is here whether we like it or not. Artificial intelligence, machine learning. Robots. It's exciting, also very frightening. Some of the biggest names in science and technology warn about the dangers of using artificial intelligence to make weapons. The development of full artificial intelligence could spell the end of the human race. This is really like the scariest problem for me. That's where we need the regulators come in and say, hey, guys, you'll need to pause and make sure this is safe. Artificial intelligence has the potential to solve all of the most difficult problems of today and tomorrow. AI will impact everything. There's nothing it won't touch. It is a renaissance. It is a golden age. Robots let people do more than they could by themselves. What do we want to use AI for? To solve problems, to be more prosperous, and to be healthy. That has to be its purpose. With artificial intelligence, the computers start to learn, to think, to rewrite, to design their own programs. AI can give us the ability to hear better, to see better, to give us new capacities that we never had before. You can pair a human doctor plus an artificial intelligence system to create new drugs that humans in a lab might not have considered before. You could see incredible expansion in lifetimes. This all sounds very Star Trek, but, believe me, that's going to happen. The question is, are we going to be smart enough to make choices as to what we want as a society? Scientists are creating AI today and setting the course for a new tomorrow. How AI changes our lives now and in the future is up to us. We're at this fork in the road where if we get things right with AI, we can help life flourish like never before and really bring out the best of us. This is AI, presented by IBM. Today's AI has gone beyond creating driving directions, vacuuming floors, or recommending new fashions. Now it really can mimic the capabilities of the human mind. AI can learn from examples and experience, recognize objects, understand and respond to language, and solve problems. Even more exciting are its future possibilities. Read on to see how AI might evolve over the next half-century. How is AI evolving? Computer scientists have identified 3 levels of AI based on predicted growth in its ability to analyze data and make predictions. They call these levels narrow AI, broad AI, general AI. As shown in the following graphic, narrow AI and broad AI are available today. In fact, most enterprises use broad AI. General AI won't come online until sometime in the future. Select each of the following levels of AI to learn more. Narrow AI. Narrow AI is focused on addressing a single task such as predicting your next purchase or planning your day. Narrow AI is scaling very quickly in the consumer world, in which there are a lot of common tasks and data to train AI systems. For example, you can buy a book with a voice-based device. Narrow AI also enables robust applications, such as using Siri on an iPhone, the Amazon recommendation engine, autonomous vehicles, and more. Narrow AI systems like Siri have conversational capabilities, but only if you stick to the script. Broad AI. Broad AI is a midpoint between narrow and general AI. Rather than being limited to a single task, broad AI systems are more versatile and can handle a wider range of related tasks. Broad AI is focused on integrating AI within a specific business process where companies need business and enterprise-specific knowledge and data to train this type of system. Newer broad AI systems predict global weather, trace pandemics, and help businesses predict future trends. General AI. General AI refers to machines that can perform any intellectual task that a human can. Currently, AI does not have the ability to think abstractly, strategize, and use previous experiences to come up with new, creative ideas as humans do, such as inventing a new product or responding to people with appropriate emotions. And don't worry, AI is nowhere near this point. There might be another level, known as artificial superintelligence, ACI, that could appear near the end of this century. Then machines might become self-aware. Even then, no levels of AI are expected to replace or dominate you. Instead, scientists hope AI will extend humans' ability to lead richer lives. Ray Kurzweil, a noted futurist, has said, "Our technology, our machines are part of our humanity. We create them to extend ourselves, and that is what is unique about human beings." Ray Kurzweil, Forbes magazine. About this module. Module 2. What are the 3 eras of computing? Introduction. In this module, you will learn about the eras of computing that progress from tabulating and programming to the arrival of AI. Learning objectives. After completing this module, you should be able to describe the history of AI, from the past to the possible future. The era of tabulation. People have analyzed data for centuries. A magnifying glass centered on one of several trees. For centuries, people have struggled to understand the meaning that's hidden in large amounts of data. After all, it's one thing to estimate how many trees grow in a million square miles of forest. It's something else to classify what species of trees they are, how they cluster at different altitudes, and what could be built with the wood they provide. That information can be difficult to extract from a very large amount of data. Because it's hard to see without help, scientists call this dark data. It's information without a structure, just a huge, unsorted mess of facts. To sort out unstructured data, humans have created many different calculating machines. Over 2,000 years ago, tax collectors for Emperor Qin Shi Huang used the abacus, a device with beads on wires, to break down tax receipts and arrange them into categories. From this, they could determine how much the emperor should spend on building extensions to the Great Wall of China. An abacus. Charles Babbage's difference engine. In England during the mid-1800s, Charles Babbage and Ada Lovelace designed, but never finished, what they called a difference engine designed to handle complex calculations using logarithms and trigonometry. Had they built it, the difference engine might have helped the English Navy build tables of ocean tides and depth soundings that could guide English sailors through rough waters. By the late 1880s, people were thinking about how to develop faster systems to record data. Herman Hall Erith, inspired by train conductors using holes punched in different positions on a railway ticket to record traveler details, invented the recording of data on a machine-readable punched card. Hollerith's cards were used for the 1890 U.S. Census, which finished months ahead of schedule and under budget. Later versions of tabulating machines had broad applications in business, such as financial accounting and data processing. Sketch of a woman using a tabulation machine. A table with 3 columns and 5 rows of random numbers with one number in each column circled and linked to a number in the adjoining column. The word to remember across those 20 centuries is tabulate. Think of tabulation as slicing and dicing data to give it a structure, so that people can uncover patterns of useful information. You tabulate when you want to get a feel for what all those columns and rows of data in a table really mean. Researchers call these centuries the era of tabulation, a time when machines helped humans sort data into structures to reveal its secrets. The era of programming. Data analysis changed in the 1940s. During the turmoil of World War II, a new approach to dark data emerged, the era of programming. Scientists began building electronic computers, like the Electronic Numerical Integrator and Computer, ENIAC, at the University of Pennsylvania, that could run more than one kind of instruction, today we call those programs, in order to do more than one kind of calculation. ENIAC, for example, not only calculated artillery firing tables for the U.S. Army, it worked in secret to study the feasibility of thermonuclear weapons. 2 women adding cables to a large computer board. An Apollo rocket firing its engines on the launch pad. This was a huge breakthrough. Programmable computers guided astronauts from Earth to the Moon and were reprogrammed during Apollo 13's troubled mission to bring its astronauts safely back to Earth. You've grown up during the era of programming. It even drives the phone you hold in your hand. But the dark data problem has also grown. Modern businesses and technology generate so much data that even the finest programmable supercomputer can't analyze it before the heat death of the universe. Electronic computing is facing a crisis. The era of AI. A brief history of AI. The history of artificial intelligence dates back to philosophers thinking about the question, what more can be done with the world we live in? This question led to discussions and the very beginning of many ideas about the possibilities involving technology. Since the advent of electronic computing, there are some important events and milestones in the evolution of artificial intelligence to know about. Here's an overview to get started. Select each marker, plus, on the timeline below in sequential order, starting with the 1940s, to learn about key events. 1940s. Alan Turing publishes Computing Machinery and Intelligence. In the paper, Turing, famous for helping to break the Nazis' Enigma code during World War II, proposes to answer the question, can machines think, and introduces the Turing test to determine if a computer can demonstrate the same intelligence, or the results of the same intelligence, as a human. 1956. John McCarthy coins the term artificial intelligence at the first ever AI conference at Dartmouth College. Later that year, Alan Newell, J.C. Shaw, and Herbert Simon create the Logic Theorist, the first ever running AI software program. McCarthy would go on to invent the Lisp language. 1970 to 1980. First AI winter caused by high expectations from end users and reduced funding. 1982 to 1993. Second AI winter caused by unmet expectations and computing power. 1997. IBM Deep Blue beats then world champion Garry Kasparov in a chess match, and rematch. 2011. IBM Watson beats champions Ken Jennings and Brad Rutter at the US game show called Jeopardy! 2016. DeepMind's AlphaGo program, powered by a deep neural network, beats Lee Sedol, the world champion Go player, in a 5-game match. The victory is significant given the huge number of possible moves as the game progresses, over 14.5 trillion after just 4 moves. Google bought DeepMind for a reported $400 million in 2014. 2019. IBM unveils Project Debater, the first AI system capable of engaging with humans on complex topics in a live debate. The era of AI began one summer in 1956. Dartmouth College, front view. Early in the summer of 1956, a small group of researchers, led by John McCarthy and Marvin Minsky, gathered at Dartmouth College in New Hampshire. There, at one of the oldest colleges in the United States, they launched a revolution in scientific research and coined the term artificial intelligence. The researchers proposed that every aspect of learning or any other feature of intelligence can be so precisely described that a machine can be made to simulate it. They called their vision artificial intelligence, and they raised millions of dollars to achieve it within 20 years. During the next 2 decades, they accomplished tremendous things, creating machines that could prove geometry theorems, speak simple English, and even solve word problems with algebra. For a short time, AI was one of the most exciting fields in computer science. But then came winter. A snowflake, representing winter. By the early 1970s, it became clear that the problem was larger than researchers imagined. There were fundamental limits that no amount of money and effort could solve. Select the following sections to learn about 2 of these limits. Limited calculating power. Today, it is important for a computer to have enough processing power and memory. Every ad you see for companies like Apple or Dell emphasizes how fast their processors run and how much data they can work with. But in 1976, scientists realized that even the most successful computers of the day, working with natural language, could only manipulate a vocabulary of about 20 words. But a task like matching the performance of the human retina might require millions of instructions per second, at a time when the world's fastest computer could run only about 100. By the early 1970s, it became clear that the problem was larger than researchers imagined. There were fundamental limits that no amount of money and effort could solve. Limited information storage. Even simple, common-sense reasoning requires a lot of information to back it up. But no one in 1970 knew how to build a database large enough to hold even the information known by a 2-year-old child. As these issues became clear, the money dried up for the first winter of AI. The weather was rough for half a century. It took about a decade for technology and AI theory to catch up, primarily with new forms of AI called expert systems. These were limited to specific knowledge that could be manipulated with sets of rules. They worked well enough for a while and became popular in the 1980s. Money poured in. Researchers invested in tremendous mainframe machines that cost millions of dollars and occupied entire floors of large university and corporate buildings. It seemed as if AI was booming once again. But soon the needs of scientists, businesses, and governments outgrew even these new systems. Again, funding for AI collapsed. Then came another AI chill. In the late 1980s, the boom in AI research cooled, in part, because of the rise of personal computers. Machines from Apple and IBM, sitting on desks in people's homes, grew more powerful than the huge corporate systems purchased just a few years earlier. Businesses and governments stopped investing in large-scale computing research, and funding dried up. Over 300 AI companies shut down or went bankrupt during the second winter of AI. Now, the forecast is sunny. Sun representing thawing of the second winter of AI. In the mid-1990s, almost half a century after the Dartmouth research project, the second winter of AI began to thaw. Behind the scenes, computer processing finally reached speeds fast enough for machines to solve complex problems. At the same time, the public began to see AI's ability to play sophisticated games. In 1997, IBM's Deep Blue beat the world's chess champion by processing over 200 million possible moves per second. In 2005, a Stanford University robot drove itself down a 131-mile desert trail. In 2011, IBM's Watson defeated two grand champions in the game of Jeopardy! IBM Watson showing the Jeopardy! Winnings of $77,147. Today, AI has proven its ability in fields ranging from cancer research and big data analysis to defense systems and energy production. Artificial intelligence has come of age. AI has become one of the hottest fields of computer science. Its achievements impact people every day and its abilities increase exponentially. The 2 winters of AI have ended. About this module. Module 3. Structured, semi-structured, or unstructured data, what are the differences? Introduction. In this module, you will learn how data can be classified as structured, semi-structured, or unstructured data and the challenges that arise when working with unstructured data. Learning objectives. After completing this module, you should be able to differentiate between structured, semi-structured, and unstructured data. Identify challenges that come with working with unstructured data. A look at the types of data. Data is raw information. Data might be facts, statistics, opinions, or any kind of content that is recorded in some format. This could include voices, photos, names, and even dance moves. Data can be organized into the following 3 types. Structured data is typically categorized as quantitative data and is highly organized. Structured data is information that can be organized in rows and columns. Perhaps you've seen structured data in a spreadsheet, like Google Sheets or Microsoft Excel. Examples of structured data includes names, dates, addresses, credit card numbers, stock information. Unstructured data, also known as dark data, is typically categorized as qualitative data. It cannot be processed and analyzed by conventional data tools and methods. Unstructured data lacks any built-in organization or structure. Examples of unstructured data include images, texts, customer comments, medical records, and even song lyrics. Semi-structured data is the bridge between structured and unstructured data. It doesn't have a predefined data model. It combines features of both structured data and unstructured data. It's more complex than structured data, yet easier to store than unstructured data. Semi-structured data uses metadata to identify specific data characteristics and scale data into records and preset fields. Metadata ultimately enables semi-structured data to be better cataloged, searched, and analyzed than unstructured data. An example of semi-structured data is a video on a social media site. The video by itself is unstructured data, but a video typically has text for the internet to easily categorize that information, such as through a hashtag to identify a location. The importance of unstructured data is rapidly increasing. Recent projections, opens in a new tab, indicate that 95% of businesses prioritize unstructured data management. Are you wondering why this is important? Why would anyone want to search through a mountain of data such as social media posts? Here are just some of the many people and organizations that might need to do this. A sneaker designer looking for new trends. Governments searching for possible terrorists. Pandemic experts trying to anticipate disease outbreaks. Financial institutions preparing for good times or a recession. Experts estimate that about 80% of all the data in today's world is unstructured. It contains so many variables and changes so quickly that no conventional computer program can learn much from it. Continue on to learn about how unstructured data is analyzed. Analyzing unstructured data. Try it yourself. Do you think it's easy to work with unstructured data? Try this thought experiment. As you continue reading, you'll encounter two different samples of dark data about the weather. Each set will ask you to answer a question about its data as quickly as possible. Find out for yourself which one is harder to answer. Now, imagine a programmable computer trying to extract meaning from billions of data like this. What kind of program would someone write that could sort out every eventuality among the clutter? How would someone build a long enough list of keywords to find anything useful? Unstructured data hides answers to disease prevention, criminal activity, stock markets, almost every aspect of civilization today. Without those answers, people and organizations cannot make useful predictions or recommendations. But AI can shed light on unstructured data. AI uses new kinds of computing, some modeled on the human brain, to rapidly give dark data structure, and from it, make new discoveries. AI can even learn things by itself from the data it manages and teach itself how to make better predictions over time. This is the era of AI, and it changes everything. About this module. Module 4. Is machine learning the answer to the unstructured data problem? Introduction. In this module, you will learn about machine learning and how it works using probabilistic calculation. Learning objectives. After completing this module, you should be able to define and describe machine learning. Describe how machine learning structures unstructured data. Describe how machine learning uses probabilistic calculation to solve problems. How does machine learning approach a problem? 2 ways to solve dark data problems. If AI doesn't rely on programming instructions to work with unstructured data, how does AI do it? Machine learning can analyze dark data far more quickly than a programmable computer can. To see why, consider the problem of finding a route through big city traffic using a navigation system. It's a dark data problem because solving it requires working with not only a complicated street map, but also with changing variables like weather, traffic jams, and accidents. Let's look at how 2 different systems might try to solve this problem. Select each item to learn how each system might approach this problem. Programmable computer. Researchers might upload onto the computer a complete database of all possible routes through the city. This is an enormous collection of structured data. Then they would have to add much more data describing current weather and traffic conditions. This would have to be revised every few minutes for the entire city. Then they might use a programmable computer to search through the data until it finds a route from start to finish. The entire project would require astronomical resources and time, if it could be accomplished at all. AI with machine learning. The machine learning AI would treat the problem like climbing a tree. The system would try a route, as if starting at the base of the trunk. Upon reaching a branch, the system would then fork in one direction and continue doing so until it reached either a dead end or the desired destination. It would do this over and over again, then compare successful routes to identify the shortest one. Although the work sounds repetitious, it requires fewer resources and can be completed more quickly. The machine learning process is entirely different. The machine learning process has advantages. It doesn't need a database of all the possible routes from one place to another. It just needs to know where places are on the map. It can respond to traffic problems quickly because it doesn't need to store alternative routes for every possible traffic situation. It notes where slowdowns are and finds a way around them through trial and error. It can work very quickly. While trying single turns one at a time, it can work through millions of tiny calculations. But machine learning has two more advantages that programmable computers lack. Machine learning can predict. You know this already. A machine can determine, based on traffic right now, this route is likely to be faster than that one. It knows this because it compared routes as it built them. Machine learning learns. It can notice that your car was delayed by a temporary detour and adjust its recommendations to help other drivers. Machine learning uses probabilistic calculation. A set of dice showing 3 and 5. There are two other ways to contrast classical and machine learning systems. One is deterministic and the other is probabilistic. Let's dig in and see what these two words mean. For a deterministic system, there must be an enormous, predetermined structure of routes, a gigantic database of possibilities from which the machine can make its choice. If a certain route leads to the destination, then the machine flags it as yes. If not, it flags it as no. This is basically binary thinking, on or off, yes or no. This is the essence of a computer program. The answer is either true or false, not a confidence value. Machine learning is probabilistic. It never says yes or no. Machine learning is analog, like waves gradually going up and down, rather than binary, like arrows pointing upward and downward. Machine learning constructs every possible route to a destination and compares them in real time, including all the variables such as changing traffic. So, a machine learning system doesn't say, this is the fastest route. It says something like, I am 84% confident that this route will get you there in the shortest time. You might have seen this yourself if you've traveled in a car with an up-to-date GPS navigation system that offers you 2 or 3 choices with estimated times. If machine learning offers only probabilities, who makes the final decision? This can literally be a life and death question. Suppose you have a serious disease and your doctor offers you a choice. Do you want your doctor to prescribe your treatment, or do you want the treatment that a machine learning system determines is most likely to succeed? Reflection: what do you think? Think about the preceding question for a moment. Then, type a sentence or two about what you might decide, and explain why. Evaluate your thinking. Does your answer account for the following? As you learned, the GPS offers different routes to choose from. Machine learning leaves room for humans to make the final decision. You, or an expert, can choose which route to take based on possible outcomes and personal experience. Consider how a machine learning system might work with the medical question you considered previously. As a doctor considers how to treat a cancer patient, the AI ingests your entire medical record plus every research paper about this cancer published in the last few years. This takes a few seconds. But the AI doesn't say, do this or do that. That would be a deterministic solution that cuts the doctor and patient out of the decision. Instead, the AI provides a probabilistic statement such as, there's a 92% chance that this treatment will work, and an 87% chance that this other treatment will work. Here is what would be involved in conducting each treatment option. Now the doctor can consult with you and together you make the choice. In other words, AI, the doctor, and you have formed a partnership in which machines predict but humans judge. Machine learning enables a rich partnership between technology and humans. AI systems and humans excel at different things. For example, you, as a person, might excel at imagining possibilities, while AI excels at pinpointing patterns. What do you think? Take a moment to consider other differences between humans and AI systems. Does common sense make sense? Graphic representation of a set of balanced scales. It turns out that in fields, ranging from medicine and education to social studies and government, the best decisions are made using a balance of human and machine strengths. But remember, there is another elusive but vital capability that must also be considered: common sense. You might know people with strong common sense and understand its value. You also might have seen or read output from machines that makes no sense. Yet, there's a contribution to be made from both sides. Common sense draws on many complex generalizations mixed with compassion and abstractions. At this time, only humans can use common sense well. The problem is that common sense is often tainted with bias that can distort your judgment. AI systems can balance this. As long as AI systems are provided and trained with unbiased data, they can make recommendations that are free of bias. A partnership between humans and machines can lead to sensible decisions. About this module. Module 5. 3 common methods of machine learning. Introduction. In this module, you will learn about how machine learning solves problems in 3 ways: supervised learning, unsupervised learning, and reinforcement learning. Learning objectives. After completing this module, you should be able to describe 3 methods by which machine learning analyzes data. Supervised learning. Machine learning solves problems in 3 ways. Supervised learning. Unsupervised learning. Reinforcement learning. Let's explore each one. Supervised learning is about providing AI with enough examples to make accurate predictions. All supervised learning algorithms need labeled data. Labeled data is data that is grouped into samples that are tagged with one or more labels. In other words, applying supervised learning requires you to tell your model what the key characteristics of a thing are, also called features. What the thing actually is. A dog on a page in a book. For example, the information might be drawings and photos of animals, some of which are dogs and are labeled dog. The machine will learn by identifying a pattern for dog. When the machine sees a new dog photo and is asked, "What is this?" it will respond, "Dog," with high accuracy. This is known as a classification problem. Train AI to classify images. Imagine that you're a supervisor at an AI research company. Practice training an AI system to classify images of animals with the correct label. Unsupervised learning. In unsupervised learning, a person feeds a machine a large amount of information, asks a question, and then the machine is left to figure out how to answer the question by itself. For example, the machine might be fed many photos and articles about dogs. It will classify and cluster information about all of them. When shown a new photo of a dog, the machine can identify the photo as a dog, with reasonable accuracy. Learn how AI clusters information. Here's an interactive demonstration to show you how an AI system labels and clusters images that are unlabeled. Unsupervised learning occurs when the algorithm is not given a specific wrong or right outcome. Instead, the algorithm is given unlabeled data. Unsupervised learning is helpful when you don't know how to classify data. For example, imagine you work for a banking institution and you have a large set of customer financial data. You don't know what type of groups or categories to organize the data. Here, an unsupervised learning algorithm could find natural groupings of similar customers in a database, and then you could describe and label them. This type of learning has the ability to discover similarities and differences in information, which makes it an ideal solution for exploratory data analysis, cross-selling strategies, customer segmentation, and image recognition. Reinforcement learning. Reinforcement learning is a machine learning model similar to supervised learning, but the algorithm isn't trained using sample data. This model learns as it goes by using trial and error. A sequence of successful outcomes is reinforced to develop the best recommendation for a given problem. The foundation of reinforcement learning is rewarding the right behavior and punishing the wrong behavior. You might be wondering, what does it mean to reward a machine? Good question. Rewarding a machine means that you give your agent positive reinforcement for performing the right thing and negative reinforcement for performing the wrong things. Learn how AI uses trial and error. Here's an interactive demonstration to show you how AI can learn through the process of trial and error to complete a task, and in this example get a reward. As a machine learns through trial and error, it tries a prediction, then compares it with data in its corpus. Each time the comparison is positive, the machine receives positive numerical feedback, or a reward. Each time the comparison is negative, the machine receives negative numerical feedback, or a penalty. Over time, a machine's predictions will grow to be more accurate. It accomplishes this automatically based on feedback, rather than through human intervention. About this module. Module 6. How will machine learning transform human life? Introduction. In this module, you will revisit the 3 levels of artificial intelligence and learn about how humans might experience general AI in the future. Learning objectives. After completing this module, you should be able to describe an ideal relationship between humans and machine learning. Take another look at the 3 levels of artificial intelligence. You learned previously about the 3 levels of artificial intelligence. The following image illustrates that the second level, broad AI, is the current level. Activity. Now that you've been introduced to what AI does and how it works, you can review these levels with deeper insight. Think of at least one time you've encountered these levels in your own life. Think about this. Perhaps, 25 years from now, general AI is expected to emerge. AI researcher Nick Bostrom defines the superintelligence as an intellect that is much smarter than the best human brains in practically every field, including scientific creativity, general wisdom, and social skills. You're likely to see general AI appear in your lifetime. General AI will enable super smart bots and technologies to link AI with the Internet of Things through embodied cognition. This will give machines the ability to interact in human-like ways as they work alongside humans. What will interacting with general AI feel like to humans? Select the following attributes for ideas on how humans might experience general AI in the future. AI everywhere. AI will move into all industries, from finance, to education, to healthcare. AI will increase productivity and enable new opportunities. Deeper insights. New technologies will sense, analyze, and understand things never before possible. Engagement reimagined. New forms of human-machine interaction and emerging technologies, such as conversational bots, will transform how humans engage with each other and with machines. Personalization. Machine interactions will be personalized for you, with new levels of detail and scale. Instrumented planet. Billions of sensors generating exabytes of data will open new possibilities for improving Earth safety, sustainability, and security. What's beyond these wonders? Humans, devices, and robots might exist as a collective digital brain that anticipates human needs, makes predictions, and provides solutions. Farther in the future, we might trust the digital brain to do things on our behalf across a broad spectrum of endeavors. You've come so far and learned so much. You became familiar with fundamental AI concepts, such as types of AI, methods that AI uses to find connections and make predictions, and ways that humans interact with AI systems. Now that you've completed this course, you should be able to define artificial intelligence, differentiate between AI and augmented intelligence, describe 3 levels of artificial intelligence, describe the history of AI from the past to the possible future, define and describe machine learning, differentiate between structured, unstructured, and semi-structured data, describe how machine learning structures unstructured data, describe how machine learning uses probabilistic calculation to solve problems, describe 3 methods by which machine learning analyzes data, describe an ideal relationship between humans and machine learning. Key points to remember. 1. Artificial intelligence refers to the ability of a machine to learn patterns and make predictions. AI does not replace human decisions, instead, AI adds value to human judgment. 2. AI performs tasks without human intervention and completes mundane and repetitive tasks, while augmented intelligence allows humans to make final decisions after analyzing data, reports, and other types of data. 3. The 3 levels of AI include narrow AI, broad AI, and general AI. Narrow AI and broad AI are available today. In fact, most enterprises use broad AI. General AI won't come online until sometime in the future. 4. The history of AI has progressed across the era of tabulation, era of programming, and era of AI. 5. Data can be structured, unstructured, or semi-structured. Structured data is quantitative and highly organized, such as a spreadsheet of data. Unstructured data is qualitative data that doesn't have structure, such as medical records. It's becoming increasingly valuable to businesses. And semi-structured data combines features of both structured data and unstructured data. It uses metadata. 6. About 80% of all the data in today's world is unstructured. 7. Machine learning has advantages compared to programmable computers. Machine learning can predict and machine learning learns. 8. Machine learning uses 3 methods. Supervised learning requires enough examples to make accurate predictions. Unsupervised learning requires large amounts of information so the machine can ask a question, and then figure out how to answer the question by itself. Reinforcement learning requires the process of trial and error. 9. With AI everywhere, AI will move into all industries, from finance, to education, to healthcare. 10. AI can increase productivity, create new opportunities, provide deeper insights, and enable personalization. Explore more. To explore topics from this course in greater depth, check out these resources. What is artificial intelligence? AI opens in a new tab. A detailed look into artificial intelligence from IBM provides more information on types of AI, the history of AI, and the future of AI. Structured versus unstructured data, what's the difference? Opens in a new tab. IBM Cloud experts provide examples comparing the pros and cons of structured and unstructured data. Distinguishing between narrow AI, general AI, and super AI, opens in a new tab, a simple, but necessary guide offered by Medium. What is generative AI? Opens in a new tab. An IBM research expert provides an introduction to generative AI and how it works. Humans versus AI, who makes the best decisions? Opens in a new tab. IBM master inventor Martin Keen answers the question, who makes the best decisions, humans or AI? Can AI help climate change? Opens in a new tab. In this video, Stacy Gifford, an IBM research chemist, explains how artificial intelligence can be used to develop new materials to help address climate change.